So, thank you, Ilka. We are here in the showroom of Janssen with a lot of elements. We're standing in front of one big facade element with my friend Uli here. And we're going to challenge each other with a few design, academic, industry topics. And let's see if we can find some mutual ground. And I want to ask you the first question. Is this facade design? We're talking.
We do it this way. Yes, of course. Well, look at the arrow.
Okay, yeah.
Well, of course, this is design. It's detailed design. Getting all these details done. That's an engineering work, yes, but it needs a design skills. You need to imagine what you can do. Yeah. So in that respect, this is facade design.
Yeah, but do you really know how old this system already is?
Yeah, that's the point.
How
old is it?
It's more than 50 years old.
But it has an evolution, I'm sure.
Yeah.
So when we look at this, and when we look at this steel section, and when we look at this aluminium part in here, which is taking the loads off the glass, that's something which isn't there since 50 years. This is maybe what? 5, 8, 10 years?
Yeah, more than 10. And then obviously also CE marking came into the game.
True.
So then we needed also to have some details with CE marking and some without, because it's really dangerous if you don't know what you don't know. But how do you deal with that?
Good point. Brings me to, say, my academic environment. I named it facade design, facade engineering and design. Well, as we just learned, 50 years, you're not going to redesign this in total. You buy it from the shelf at certain points. Yeah. But what you need to do is you need to adapt the from-the-shelf components to your design, and that's the facade design, facade engineering, which we are dealing with. So in that respect, yes, this is a kind of facade design.
Okay.
Next yellow sticker.
Yeah, I got one about R&D versus design. So let's say you are the R&D and I am the design maybe, because we have to do the work which you study and give us thesis, conclusions. How do you deal with that?
I'm not sure if there's a versus. So yes, we do R&D, yes, we do technical development, but we do also, say, functional development, and yes, always this always has a part of aesthetic to be developed as well. So R&D, research and development, ends up in technical solutions. But these are the platform for design. So if you're, say, the architect, the designer who wants a certain shape, who wants a certain functionality, which I would call part of the design as well, then these R&D developed solutions are supposed to be part of it.
Yeah.
And yes, we have to end up with, say, design opportunities. So we try to not do a specific aesthetic design. We try to be off of that to allow, say, the ones which are then using it for their objects to identify their own interests, but using this technology.
It's exactly my point. I think when you think of design, you can design for transparency or to make something very beautiful, but I want to ask you, in your work, is there also design for, we call it longevity because it has been around for 50 years and more, but you can also design for other purposes. How many of those purposes are you dealing with?
That's an interesting... The nice thing with research is you end up with a research question and you make it to a certain point, and when you end with your answers to your research question, you always know another 15 questions more. Yeah. So it always gets deeper and deeper. So the more we know, the more we know what we don't know, what we need to investigate, get more. I did my PhD in the structural use of glass. So that was supposed to think about transparency. Yeah. So transparency being the driver for structural use of glass, you end up with glass plates and lamination and all this kind of aspects. And then transparency, then technically this finds interesting solution, but then transparency, because of all the layers, becomes less. Yeah. And that's, say, an interesting interaction between the pure design aspect, getting the minimum structure, versus the technical aspect. And this is a constant balance. So when we would, say, redesign this and would try to make it an entire new setup, 50 years, We may end up with a lot of technical questions, but it will influence the design.
Yeah.
So I wouldn't call this R&D versus design.
No.
It's actually R&D improving,
Integrated.
empowering
Yeah.
design, but also, and that's an interesting one when you start working with architects, they come with crazy ideas. Can I please get something which is impossible?
Yeah.
Which is obviously their interest to show, but also obviously an opportunity to prove certain new features in a building. And then it's interesting to see that design improving the R&D. Where would you be able to make something out of it?
Something crazy.
Something crazy.
I remember an old statement or a research question like, is this stick system, this is actually a stick system, Vost and Riegel, is it going to stay? Does it have a future?
Yes.
Okay, thank you very much.
Well, different materials, we see them in steel, we see them in aluminium, we see them in wood. We're going to see them in paper.
Yes.
You're not able to sell it now because my research is not finished. I need another 5 years to get this, but then that will happen.
Yeah.
So, say, the systematic, I very much believe, and it has quite some technical potential, and it has a huge, say, experience in the design environment as well as in the manufacturing environment.
Yeah.
So the people building it, the people producing the components. Yeah. So I very much believe that these systems are going to stay. They're going to adapt a lot. We earlier talked about opportunities for future research.
Yeah.
Disassembly, that's something which is really going to be
That's maybe for later on.
Okay.
Let's keep that one in mind. Okay. You're talking about paper also. This is very maybe scary for us where we're selling steel. I'm kind of a hybrid guy.
Look at this system. Here you have steel, you have a piece of aluminum, you have glass. You're not selling steel.
Exactly.
You're selling an entire system.
Yes. We're selling daylight also.
Yeah, well, you name it like this. Yeah.
We sell daylight. So
this is where it becomes narrow. Yeah, okay.
Yeah, it becomes narrow. Okay, maybe another one because we hear things from the market. So there's a market demand, and then we have a few conversations. Then we're again talking about design. Are you accommodators in any way with research? How does that work?
What do you mean with demand versus design?
Like the market asks us to be sustainable.
Yeah.
How sustainable are we actually?
That's a design question.
Yeah.
So we see common trends following, say, the needs of our society, and architecture always reacts to that. At some points, architecture is even pushing faster than some of these trends are, say, normally seen in our society. Yeah. And then if you call that architecture the design, then this pushes obviously the market. Yeah. So the market has to react. So you have to react to that crazy architect coming with the question of a paper facade, which I can't promise yet.
Yeah, exactly. And then how long does that all take? We're talking about that for decades.
Yeah. There are fast runner projects.
Okay.
Which say from the first initial idea from an architect till a building may, if they're really say fast and the finance works well and the client is in and the companies which are supplying it are in, that may take 2, 3, 5 years. Yeah. And there are other things which are larger, which are not the one-offs in say unique situation with authorities accepting a lot. Yeah. That may take a bit longer, and in that respect you're more into system. And then, well, we're now talking for the Benelux, but when you look at the German market, for example, there's quite an offset. Yeah. So legal acceptance are an aspect of this as well. And then it can take 10 years. For me personally, in my research, when we come with an idea till, say, the PhD and the second PhD is finished and I see the product in the market, 8 to 10 years. Yeah. That's from the very first stupid idea where everybody believes this is entirely bullshit till a product in the market.
But then you will continue. Either if you think, well, it might be bullshit, might make it, might not make it, you continue with it.
Yeah, it's true. That's what we do in Delft and in Darmstadt. Yeah. We have a lot of balloons and some don't make it. Yeah. Well, that's the good thing in research. If you know that you don't make it, you still have a result. That's not good for, say, a product. But there's a lot of these activities happening, so there's a constant wave of new results getting into the market.
Also maybe challenging students. It might not make it, but it was an interesting voyage.
It was an interesting voyage and an interesting experience. And even even the mistakes are important because you learn from the mistakes.
Exactly.
That's how I was taught by my professor in the beginning. He said to me, if you investigate something till it works, this is engineering. You have to come to the point when it breaks to really come to science. So I always have to overstress it to the point that it really breaks, and then bring it back this level which is necessary to make it a normal product which can be given with warranty and people rely on.
How do you look at us? We'd like to contain it and control it, that we really know how the system works and performs. So we like to stay safe. And there is a border between really safe and challenging.
Yeah, you have different levels. You have these standard systems which you have to sell to a market price which you're competing with others, and that has to follow a certain safety regulation, technical regulation to fulfill its needs. That's something which is quite narrow as a range. That's the one part. Then the next one, which is the one-off projects, which you do as well. So you design something very special, a special detail which somehow helps. That needs to then be proven. And then you need to do all the technical investigation, approving the certificates which are necessary, which is possible in a certain range. And then we come into the picture as, say, the ones coming with the wild idea. And with Janssen, I'm happy to be able to do this kind of things. They are open to accept weird ideas. And then you come with something which we're going to see later as well, and in the burst as well, which somehow solves technical problems which we couldn't solve before. So not situations which may be different. And that's something where it's interesting to identify these companies where you're able to really move this border by also having them investing into this in time, in budget, in experience, to develop a certain technology. And that's why I say, well, this is where our relation starts.
Yeah, exactly. So it is an interesting development that we have going. You can see it later on next year, but how do you look at Janssen as a company? Was that a surprise that we wanted to go this far out of our comfort zone, maybe?
Yeah, I didn't expect it. Sorry, you're a system company.
Yeah, sorry.
And it has a certain history. They say the typical setup of how these systems are manufactured, engineered, sold, brought to the market. And these system companies are normally quite, they're tankers.
Yeah.
They're not armadas where you have a lot of small boats. They're tankers. You laugh at it. So they move to a certain direction. So if I come with this weird idea as a helicopter onto the tanker, I actually need a speedboat next to it. So luckily I got a speedboat here, which really pushed very much. Well, we talked to them earlier today, which brings it to a certain point. We're not allowed to talk about it.
No, well, we have to leave you in suspicion a little bit.
It's
just a few months.
It's super cool.
Well, it will be cool. Yeah, it will be cool. Other part of the scale, maybe this was very challenging. Going into details, another development is design not versus sustainability, but I would say for sustainability. This is a big one. This is very broad.
Yeah, this is super broad. I agree. It's not versus. It's actually for sustainability or for circularity, as you name it in the Dutch environment. Again, define circularity or define sustainability. Is it only the energy consumption of the building? Or is it the energy consumption of the building, what we now believe, building plus the energy necessary to make something? So the embodied energy as an activity or as a consequence. And then next level, which makes it circular, how can we reuse it? So how can we either reuse real one-to-one components? Interesting field you're investigating, or how can we say disassemble certain parts and then use at least these subcomponents? That's an interesting one. But give me a second.
Okay.
Glass and steel, materials which could melt. So they're actually, if the energy is solved, they're a good material to be really recycled.
Recycle. In the hierarchy, reuse is higher.
Yes,
So
absolutely, I agree.
is it worth the journey to recycling is easy, but is lower in the hierarchy? Is it going to be worth it to try and go for reuse?
Absolutely. Quite complex. So 2 levels. The first level is rethinking this detail to be easier able to disassemble later and new assemble, which then obviously the length is an issue, so you're cutting it shorter and shorter and shorter. Let's say the one aspect, and the other aspect is rethinking all the existing structures which you built since 50 years, hundreds or thousands of square meters, and how can we use that and disassemble it as necessary and then reuse it. That's I totally believe the opportunity. So yes, you're right, the pure recycling, crunching it, melting it, making new, that's an opportunity. That's the last step to do. But when we are able to use the material as they are already made in a new situation, that's an interesting one.
But we don't need to or should only talk about the material. It's also the whole data set around it. You need to identify where those old projects are. Are they going to be interesting to be taken apart and reused again? So reverse BIM maybe comes into the game.
Yes, and you don't have data. You don't have any RFID chips to the old facades, but you may know where they are.
Yeah, we do know about.
And then systematic of how to deconstruct them and how to store them, and then how to actually part of reusing maybe even the simpler one. The deconstruction may be the more complex part.
Yes, we find it very complex. Then you're talking also about investments because it's not economically interesting today. Do you think that maybe in short term?
No question. Absolute. Absolute. I totally believe it. You see so much this trend towards reuse of material. Material is going to be the future problem. The energy problem is not yet solved, current situation especially, but this boost towards renewable energy is so clear that, say, in a certain time we will come to the point that the material is a problem because the energy will be mainly renewable. Not now, but clearly to be expected. And these constructions made for 50 years. So in that period, of course, this will happen.
I think we answered it maybe both. There is a future for steel.
For sure, there's a future for steel. It has a certain quality, no question. And it's a material which could be recycled, no question. Okay.
Then I would really like to thank you a lot, Uli. We'd like to challenge the audience and really stress that next year in April, we're going to put a very, very interesting element on the bow, and you know all about it. So you simply have to come to the bow in Munich next year in April. Ilkar, we're coming back to you, and we hope we see the audience at bow. And you, Uli, thank you very much.
You're very welcome.
Okay.
Good to talk.
Good to talk.